Video for the heart dissection, and after the analysis questions, like that I answered after the doing the dissection. So let's see. Here's a heart diagram of how the heart is supposed to look. Obviously, we did a dissection with the sheep heart, so it's a little smaller than the human heart. How can you tell which side of the heart is the ventral surface? So for that one, you, Mr. Loftus, help me out figure this out by pouring water into the superior vena cava. Of course, this was a hole, so you poured in water through there and then squeezed it, and then well, first it was in we poured water through the aorta, and then after we squeezed it, it went into the right atrium. So that's how you figured out which was the ventral surface, because you held it up and you showed, oh well, even though it looked like the backside, you were like, oh well, this is how it's supposed to look, and it helped figure out which was the left and right side of the heart. So let's see. It says, how many chambers are found in the mammalian heart, which is the heart of the mammal. All mammals have in their heart, are 4 chambers. The right atrium, left atrium, right ventricle, and left ventricle. Which chambers are the pumping chambers of the heart? The pumping chambers of the heart are the right and left ventricles. Let's see, which chambers are the receiving chambers of the heart? That would be the right and left atrium, or atria. And then let's see, it says, describe the action of the tricuspid valve when you squeeze the water-filled water and then fill the right ventricle. So when the water was put in through the superior vena cava, as you squeezed it, what should have happened was that the tricuspid valve opens, it lets the water go into the right ventricle, and then after that it closes, because it's supposed to. After that, it closes, and then it goes into the pulmonary arteries, and then pulmonary valve goes through the pulmonary trunk, and then it goes into the lungs through the pulmonary artery, and then it returns. So that's what was supposed to happen, at least with the tricuspid valve. Then it says, compare the structure of the tricuspid valve and that of the pulmonary valve. Well, the tricuspid valve looks to be bigger than the pulmonary valve. The pulmonary valve looks like it's open. One reason for that, I believe, is that the tricuspid valve receives, after the right atrium receives the blood, the tricuspid valve closes. It's closed. After it gets compressed, it goes into the right ventricle, which after that is supposed to shoot the blood straight through. So it made sense that there's such a little space, but at the same time it looks more of like when you walk through the door or walk through those swinging doors. It's just you're supposed to go through, not completely shut, but just let the blood flow. Just in case people would want to keep walking. The door would just be like this. All you have to do is push, and you would go straight through without having to be much work put into it. Let's see. How do the walls of the atria compare with the walls of the ventricles, and why are they different? Well, the walls of the atria, these two, are thinner. As I was doing the dissection, I realized that they were thinner. And the reason why, I believe, is because they were just receiving the blood. You just received the blood through here. But the walls of the ventricles were thicker, and that's the reason why for that is or the reason for that is because the ventricles are the ones that pump the blood through through the arteries and through the rest of the heart, or well, not the heart. Oh my goodness. Well, as I was saying, sorry, they pump the blood to the rest of the body, so they need to push the blood with a lot of force, because it's a lot of blood and it needs to flow to your entire body. So they need to be thicker, filled with more muscle to do such a thing. let's see. What is the purpose of heart valves? The purpose of heart valves, the valves control the flow of the blood through the heart by opening and closing during the contractions of the heart. Name and compare the heart valves found between the upper and lower chambers of the right and left sides of the heart. Well, from the diagram, you can see that there are four valves. The tricuspid valve, pulmonary valve, the aortic semilunar valve, and then there is the bicuspid valve. I think, like when you compare them, you see that, the tricuspid valve and the bicuspid valve are the ones that are, like bigger, and they actually look like they close, while the aortic semilunar valve and the pulmonary valve are a little bit more open. There's a little bit more space in between them, to get the blood through a lot faster, So I think that would be the biggest difference, the size and the way that, they close, and how the two other valves, the pulmonary valve and the aortic semilunar valve, don't close, or don't seem to be closed. Let's see, this says, vessels that carry blood away from the heart are called arteries, while veins carry blood towards the heart. Which artery is the largest and why? Well, the largest artery is the atria. The atria is the largest artery, and the reason why is because, I believe that, you get the biggest amount of blood, like it needs to be big, so you need to carry big amounts of blood to the rest of the body. You have, the right and left sides of your body, your arms, and then this middle one would be towards your head. This bottom one would be towards your legs. So, it needs to carry blood all over your body. It needs to carry big amounts of blood for that, so it needs to be big. Let's see. What is the purpose of the coronary artery, and what results if there is a blockage in this vessel? Well, the purpose of the coronary artery is to carry blood to the heart. Arteries are supposed to carry blood away from the heart, but in this case, they carry blood towards the heart. The coronary arteries, there are three of them. One would be going through here, and what happens if there was a blockage? You wouldn't receive the blood, wouldn't go to the heart. You wouldn't be receiving blood to the heart, and of course, that would be bad, because your heart also needs blood, which is pretty funny, because it pumps. It's the instrument to pump the blood to the rest of your body, but it also needs that blood to go through it to do that action as well. Let's see. Can an artery carry deoxygenated blood? Yes, an artery can carry deoxygenated blood. The pulmonary artery is the one that carries deoxygenated blood. So the deoxygenated blood enters through the superior and inferior vena cava into the right atrium, which goes through the tricuspid valve into the ventricle, and then the right ventricle, when it compresses, it goes through the pulmonary valve, and when the pulmonary valve, this is deoxygenated blood, it goes through the pulmonary trunk into the pulmonary artery, and then it goes into the lungs, and then it returns into the pulmonary veins, these two set of veins, as oxygenated blood. Well, now I will show you how the blood flows through the heart. I will also have a separate diagram showing you specifically how, but this is really, really quick. So you have the superior and inferior vena cava, which receive deoxygenated blood, and it flows into the right atrium, which goes through the tricuspid valve, and then it goes into the right ventricle. When the right ventricle compresses, it goes through the pulmonary artery, or pulmonary vein, pulmonary valve, and then it goes through the pulmonary trunk into the pulmonary artery, and then it goes into the lungs. When it returns from the lungs, it goes through the pulmonary veins, and then it goes into the left atria through the bicuspid valve into the left ventricle, and then it goes through the aortic semilunar valve, which goes into the aorta and gets distributed throughout the rest of your body, your arms, and then your head, and your legs, the bottom part. So that's how the blood flows through your heart. And as a reminder, Heaven was the one that was in my group, and she was the recorder of throughout the entire dissection. She recorded everything that I told her. While I was doing the dissection, she would tell me the questions that needed to be answered. She helped me out with moving the papers to see exactly which questions needed to be answered and what I needed to do. So yes, I'm giving her credit because she was the recorder, just to, letting you know I'm doing the video from my home, so there's no way that she could do it with me. Well, I just wanted to let that be cleared out. I'm giving Heaven credit for, being the recorder of the entire dissection. And yeah, that was my video.